I think we go right over into the presentation and into the demos. So you will see at least two demonstrations. It's basically my session is very demo based. I want to show you how I helped customers with partitioning to boost their performance. And I have a few scenarios which are all coming from real world scenarios. So first of all, if you want to download, demo database, feel free. I have a big database which is around 70 gigs, lots of data in it. Or if you want to test or play around with a smaller one, then use the customer orders database, which is around 500 megabytes. The slide decks and the demos can be downloaded from the link here at the last top here. It's partitioning for data management in the bit.ly. So this is me. Forget about all the commercial things here because we are short in time. Just only notice my email address. So if you have any questions concerning data partitioning or anything what's going on with Microsoft SQL Server, the database engine, then feel free to drop me an email, and I want to send you. I try to send you immediately an email with an appropriate answer to this. So here we come. All user cases which I describe in this session are based on real world scenarios, and I've found the implementation into production. The customer scenarios have been strongly simplified for this session because I don't want to go into the details of the whole system, but only want to concentrate on the problems, what we finished with the partitioning. So here comes the first user case for partitioning. By the way, I need to mention that I do not explain too much about partitioning itself. That's basics, what you can have in books online. But I want to show you the technique of partitioning and how it can improve the performance of the workloads. Here is the first one. This is a high transactional production environment, and my customer is a pharmaceutical company that is producing drugs on various production lines. So I take 16 here as an example. The problem here is that every single drug needs to go through a quality check, and then it stores the results of the quality check in a SQL Server database. The use case is quite simple. So you see here at least 16 machines, and we have one or more web servers with web services running where all the machines are pushing the data to. So depending on the product they are producing, it could be less or it could be a huge amount of data. And these web servers are gathering the information, and then they're pushing them into a SQL Server database. The biggest problem was when we were dealing with machines which had a huge amount of data, and what we saw that latest at 10 o'clock in the morning, the queue to push the data into the SQL Server was quite high. And the problem was, or the bottleneck was, the database itself. So what we saw was that lots of processes were hitting the protocol table and the machine data table, and so with 16 of them, we had lots of so-called page contention. And this is something what they wanted to stop. And I figured it out with the developers, so with the vendor of the software. And I was running an investigation on the database, and we were figuring out that the problem was coming from a so-called page latch contention on the database itself. So here's the use case in detail. A very simplified table called machine data. And what you can see from the table is that every single pushes the data into the table, and the machine ID, the ID, then the column C1 for the production data, and a timestamp for that. The developer was creating this database just only on one single data file. And the biggest problem we had then was that the storage was really fast enough to transport the problem occurred before writing to the disks. So the data in the queues SQL Server could not save the data quickly enough. We figured out that we had some tension, which was the problem of the database design, and the database to scale this. The second thing what came into our mind was that the index, so the clustered index on the table, it was really heavily fragmented because of the single different machine IDs. The problem is that this clustered index was on the machine ID and on the timestamp. And yeah, this needed to be figured out how we could solve this. So we were seeing that the storage was fast enough. That was not the problem, but the optimization was on the database phase itself. So let's switch over to the demonstration, and therefore I've prepared something. What you can see here is my my databases I have, and now I think we start up with that. Here is my first demo, speed up your high transactional system. I hope that everybody can see the script, it's large enough. And here we go. I create my customer, so my demo database first. And after this table has been created, the database has been created, I now go ahead and create a very simple design of the table. What you can see here is that I have a machine ID. So for every single machine, we got a dedicated ID. Then we have the timestamp, and then I have for the payload a very simple column with which is called C1 with a fixed character length of 1 kilobyte. So after I've created this, come on. Oh, it's executing. Just give me a second. That is live. One moment, please. So you know that the problem here is currently I have my OBS running, I have the web page running, I'm streaming, and I just only have a very small and tiny computer here. So once again, I start to create my demo database. Come on. It's executing. You see, it's the CPU is maximum. Let me see. That's because of the stream. Yeah. Out. Man. Okay, let's check it out. Let's do it a different thing. Don't worry. Refresh. Hey, what's going on here? Yeah, to stop something here. Let me see how the CPU is here. Yeah, you see this? CPU. It's my here. Yeah, and that is the software here for streaming. Yeah, let me try to figure out how I can fix this. Yeah, I know what I do. Just a short interruption. I will change the camera and I will share another. So I think that you can see this now. Okay, so now I have more power for me. Okay, so once again, I try it again. So I create my demo database. So yeah, fine. Okay, so now I create my table called machine protocol. And here you see that I have my machine ID, I have my timestamp, and that's the payload, the column 1. So here comes the original query, which was coming, the original index, which was coming from the vendor on the machine ID and the column D1. And here is a very simple stored procedure. This stored procedure will enter periodically protocol data into the table. That's a very simple thing. Insert data, insert data, insert data. Okay, so that is done. And now I want to track on in my system here, and therefore I will start an X event. And this X event makes it possible for me to track everything what's going on. And you see here that I want to figure out what weights are currently occurring in my database which take more than 1 millisecond of time. Start this. Now I can go ahead and can run a session with 16 machines which are entering 10,000 entries. Therefore, I have a simple batch file where here you can see that I start for every single machine the stress tool from Microsoft called OStress, and then I said just only please repeat 10,000 times and fire 10,000 times this stored procedure, and I do it simultaneously for 10,000 for 16 machines. Therefore, I copy this one here. Now I start this on top of my heavy running machine. So here we go, and now it's starting with 16 machines. They are pushing the data now into the system. So while they are doing this, let me have a look to the ledge contention. Go into my management. Oh yeah, it's okay. Here it is, extended events. Here is my high transactional system. You see that I'm recording this, and when they are finished, I want to check out what was going on. You will see here that the 10,000 spins were taken around approximately 30 to 35 seconds. Problem now, as I said, is that my CPU is so heavy under pressure here with the streaming that it will take a little bit. Yeah, you need to have the time here, but it's running, and yeah, there are 16 machines now pushing the data. So in the meantime, put it away, and I want to see what is going on in my system. Therefore, what I'm doing is I'm reading the recorded data from the X event, and then I want to see how much ledge contention on the system. So let me see whether it's finished. Yeah, it's running. Good to know. My CPU is so much under pressure. You see it here. This is my browser where the software is running in. I'm really sorry about this, that it takes so long. Okay. However, I try to get the data in the between while it's running. And so here you see this. And what you can see here is that we have so heavy, extreme heavy wait times here, 600 milliseconds, 32 milliseconds. And you see here on what page we have this. And this is because of inserting data. So many entries here, and that makes the system so incredibly slow. And here the point, the system cannot scale. So what can we do against this? The issue is here, as I said, not on the storage, but on the database itself. So we need to try to spread the workload over different files, and that makes it a little bit easier because the file or the storage was not the problem here. So what can we do? I go back into my into my speed test. So is it running? I hope it's done now. Unbelievable. It's really unbelievable. Unfortunately, you can't see me. I'm sweating here because of the heat coming out of my laptop. See whether I can run a query against the wait stats of SQL. And here comes a very interesting thing, and that is important for you to see and what the problem are. The write block defines that the server wants to write in the log file, and you can see that it was taken approximately 1 millisecond. So the storage is definitely fast enough. On the other hand, I have some problems here with CPU. Yeah, why not? And the big point comes from here. And you can see here that we have lots of waits only on the pages itself, page ledge shared and page ledge X. X is for writing. So the biggest problem is here definitely waiting on the resource in the database itself. Another really extreme big problem is this one here. I now want to see what is about my indexes. So I have just only one clustered index on it. And what you see here now is that we have an extreme heavily fragmented index here. It's by 98%. And the reason for this extreme fragmentation is very easy to explain. The clustered index is on the machine ID and on the timestamp. So every single machine is pushing the data into the table. So the first column is the machine ID and then the timestamp. So if the machine number 2 is writing data and afterward the number 1 is coming, then this row needs to be inserted before the previously inserted machine data from machine ID 2. And that makes the table so extreme fragmented. So what can we do about this? The key point, what we figured out was that every single machine needs to have its dedicated file. And if we write the data from one machine to just only one file, then it seems to be that we can better scale our application. So I think it's finished now. Oh, you see? Yeah, come on. Yeah, it is finished. I know this. So, and you see here that it was taking, oh my goodness, 5 minutes. This is really incredible. Basically, it should be 35 seconds. Okay, so what was our solution? We delete the table entries because I want to restart it again. And after this, I now partition my database. What does this mean? What I create here with this script, it looks a little bit complicated, but it's quite easy to understand. I go in a loop from one machine to the next up to 16 machines, and then I create for every single machine a dedicated file group. A file group is a logical container where I can put data files under it. So after I have created the file group, I then create a separate database file specially for this file group. And when I run this, so that must be quite fast. Okay. So now see, I stop this session again first, please. Sorry. When I look into my database, here is my demo database, and I look into the properties. Then here you can see from the file that I now have for every single machine a dedicated file group. This file group, as I said, is a container. The physical parts that are in files. You can see that for every single machine file group, I have a dedicated file behind that. And you know what the cool thing here is? Let's say 16 different drugs you are producing, and you know that one of them are having extreme heavy workload, then just put another file dedicated for this machine into its file group, and then it can scale way better. So in total, your system can scale way better as before. But this is only the physical layer here, what I did. The physical layer now needs a logical layer, and the logical layer is coming from partitioning here. What I'm doing is I create now the partition function. The partition function is the logical part where SQL Server will now get the information only for the IDs which they want to store, where I want to separate my data streams. You see from 1 to 16. And the last step is now that I need to combine the logical layer with the physical layer of the database. Therefore, I create a so-called partition scheme. And this partition scheme depends on the partition function here. 1, 2, 3, 4, and you see that the 1, if there is data coming in from number 1, and it's then the partition scheme makes sure that the data from the partition number 1 will go into the first file group, second, third, and so on. So it gets created now. Now I drop the index, the original index on the table, because I want to make this clustered index now using partition schema. And that's what I'm doing here. And you see, with this single, I tell SQL Server that please divide the table machine protocol on the partition schema, and the partition schema get filled, so it's data driven by the machine. Let's do this. And I will delete, 1 second, we'll delete the old wordings. This is in the trace files. We go and finished. Now I restart my extended event, start my session. I clear my counters. Done. And now I run exactly the same workload again. So come on. Okay, here we are. So again, with 16 machines, and while I'm running this, I want to show you a very interesting feature now. Go into my resource manager. So it's time for you to learn a little bit. Unfortunately, my Windows machine is in German. But here you see my file structure. And here is my SQL Server. Give it a little bit. So now the system is pushing the data into the table. And what you can see here is that SQL Server is writing with 6 megabyte. And give it a little bit time, and you will see then, yeah, here it is, that now we are filling every single separate file here on my SQL Server. So the throughput on the storage is now way better than it was before, because we only were writing into just one file. But now we are writing the data separated for every single machine in one dedicated file. And the log file, that is okay, because every single row goes first into the log file. So now you see that the system is finishing here. You see that it takes 1 minute instead of 5 minutes. And this is really unbelievable. The first part, I have to admit, is that the system currently is not running with so high CPU load. But basically, it is around, in this case, 80% faster. But in reality, with our customers, we had an improvement of around 10%. But the more interesting thing here is two points. The first one is, I want to check, hey, SQL Server, for what was you waiting here mostly? And what you can see here is that you do not see any latch contention here. So you maybe remember the page latch SH and the page latch AX. AX is for writing. And I don't see anything here. So the write block is the the highest value. That is okay. But in total, my system was way better scaling. And the really interesting thing is when I have a look to my analysis of the X event, have a look to this. Takes a little bit, it's okay, because it needs to run the query, and have a look to this, to the latch contention I have in my database. It's nearby nothing. The number 9 is just only a system page, but I had just only one exclusive latch where I was waiting for on one dedicated page. And that is the reason why the system was so fast here. So every single machine or the web service was at that time not waiting to gather a log, but it was permanently writing. And that is really incredible. One other point what came into account was, you remember that the index fragmentation was incredibly high. So when you're reading data, it was permanently jumping in between the data file to gather the data. But now I have absolutely nothing here. This 0.5%, to be honest, it can completely be neglected. And you see that every single partition now has its 10,000 rows, no more fragmentation in it. So when we read data from one machine, then we can speed up the reading of the data if it's not in memory by hitting the storage, and we can use the feature read ahead mechanism. That is incredible fast for this one here. And that gave us a good opportunity, and the customer were so happy about it because we didn't have observed any more waits on the web service. So the queues were all the time completely clear. That was a fantastic quick win we had with this. Yeah, it doesn't. Okay, yeah, I deleted this. Refresh this. So this was the first one. Our performance improvement were 3 to 10%. That was based on a single machine. And what you can see here is that what we were doing, we were separating for every single machine, we created a separate file group with its underlying file under it. And the good thing was that if one machine was pushing way more data than others, then we just put another file under this file group and the system was scaling way better. That was really a true great benefit we had. The last demo I want to show you is about a data warehouse. This data warehouse scenario was very interesting. So one of my customers is one of the greatest supermarket chains here in Germany. And what they were doing every single night, they were grabbing the data from every single cash desk, every single, over an FTP server, and they pushed it into their data warehouse. So that was happening every single night. And the problem was, the first time it was working very fine. But with every new supermarket and every new cash desk they got, they were running more and more into problems. And the scenario was very easy. So the information about a cache desk was pushing to a web service, FTP server, and the FTP server was doing a bulk load to the DB server. Calculation are not possible while the import is running. So let's say one supermarket was finished, and it would be quite interesting then for the customer to make the calculation for the product they need to ship to the supermarket. They can see it from the goods which have been sold. But the problem was, while the bulk load operation was running, nobody could do any calculations. And the second thing was, we could not do any parallel processing, because the parallel processing could not happen if one supermarket was pushing the data. We got an exclusive lock on the whole table. And while we had this lock on the table, no other process could push data into it. So here comes the demo for this. Speed up the workload. I again create my demo database. Now it should go fast. Here I need to go out of this. Yes, come on. Done. And what I'm doing now is, because I do not have a web service, an FTP server, I put some data into a staging area here. So therefore I create a new schema in my demo database. And then I create the two tables, the cache analysis and the cache activities. The cache activities is the data which are coming from the cache desks. So here is the first query where I put a few data into my cache activities. So every single line from every single product you bought is now in my table. So it's around 3 million or 9 million rows. Perfect. So then I create a clustered index on the cache activities for every warehouse and cache desk. So it takes a while, 9 million rows. And here is my distribution of data after this has been created. So now I hear my CPU running again. Hi, come on with this. So while it is working above, I go to the next step. Here is my cache analysis table. The cache analysis table will go and aggregate every single article name to see how much did we sell from that and what is the total price. So this is my table. And now I create a warehouse log table to measure the date with the time which it took to load it. And here is my workload. What you can see here is I hand over the warehouse ID, and after this I go through the cache activities, and I go through every single cache and accumulate the data, and then I'm pushing the data. Let me just refresh this. And then I'm pushing the data into my cache analysis. And then I take the next one and the next one and the next one. So while it is running, I measure the data and I write the data into the warehouse load. So this is my stored procedure. Go for it. I clear my weights, and now you see my workload, which is going. I go for 16 load processes here again, and I run it for every single warehouse. So here's the warehouse ID 1, 2, 3, and they have, to be honest, in Germany over 1,200. And what I want to achieve here is that they can run in parallel. But this won't work here because, as I said, when one is writing, it is completely blocking the table. So here we go. Now I run the second workload. Take a while to create them. And while they are running, I want to check out, hey, what are the processes waiting for? And these are my requests. You will see that it takes a little bit. So here you see. Here is the status of the processes. And let me do it this way. So the runnable does mean that this process has all information requested. And now it's just waiting for the CPU to get the data from it. On the other hand, you see suspended processes. A suspended process does mean that this one is waiting for some information or is waiting for a resource. And I hope to make it visible here. You see here, look to this, they are all waiting to get an exclusive lock on the table. But the problem is they can't because one process is getting that and is blocking everything else. And that needs to be released. So let's see whether it's finished. Here you see they are just coming on. And look to this. This is really interesting. So when one was finishing, it was only 517 milliseconds. But then we see 38 seconds, 25, 20, 47, and so on. And they go longer and longer and longer and longer. And that is because when one process has finished, it released its lock, and then the second one is coming in and say, well, okay, now it's my job, and I need to insert my data. In the meantime, the other 14 were waiting. And the problem here is that the system could not scale this. So the maximum was 1 minute and 30 seconds. In the real world scenario, that was not just only 1 minute. It was taken from half an hour up to 4 hours for the last one. And you can understand, I think that you can see that this is not scalable, that cannot work for them. So what we did was, first of all, we analyzed the information. Let's see for what SQL Server was waiting. And yeah, this is definitely the biggest problem we have here. You see how often SQL Server was waiting. That is the amount of numbers, how often SQL Server was waiting. And my complete system is dominated by the exclusive page latch wait. So in simple words, we are queuing here and we were just and everybody was waiting for getting access to the table. The write log, this is something what I want to see at the top because I want to write the data and I want to have an equal loading process here. If I look to the warehouse load, this. Here you can see how much time it was taking. The last one is not so important, but this one is okay. You see it was taking 45 seconds, 33 seconds, and so on, 80 seconds. And this is something which we don't want to have here. So what can we do about this? And again, partitioning here is it's a solution. So here is my difference. Let me check this one. So that's max. The min was 24 seconds. In average, we took 60 seconds for loading the data. And we go again with exactly the same process. I truncate my table cache analysis. And then I want to see, let me see. Yeah, I do just only one data warehouse to show you in detail what the problem is. Therefore, what I'm doing is I want to do one import for a data warehouse, for just only one warehouse. And when the warehouse gets filled after this process, I want to show you what resources are blocked in this scenario. So here you see the problem. This one is okay, that's fine, but look to this. The table cache analysis is exclusively blocked. An exclusive lock does mean that when one process is writing the data into a table and has an exclusive lock on it, then it does mean that nobody else can write on this table. So we have a very bad situation here in this scenario. So, and the only thing to solve this is to spread again for every single warehouse the data onto different partitions. So here we come with this. I again create for every single warehouse a separate file group and a file. This is done so far. When I check the file groups, you now can see here that we have the primary, which is fine so far, but here for every single warehouse from 1 to 15, we have now the separate files again. I create my partition function for that. This is the logical part. And now I want to bind the logical part to the physical construction, which has been implemented in my database. So now I create my partition scheme. 15 warehouses. By the way, just an information. It might be that you say, oh, come on, you told about that this customer is over 1,200 supermarkets. Don't worry, you can use up to 15,000 partitions. 15,000. So that means for my customer, well, they can grow. Did I do this? Yes. Okay. So now I redesign my cache analysis table, and here I create my clustered index on every single warehouse and on every single cache task and put it on the partitions. And now you see how the data will get distributed to this. You see the table here, table name. You see the index, that the index is now for the partition 1, the file group number 1, and so on, and so on, and so on. We currently do not have rows in it because the process did not start so far. Okay. I reset my performance counters for a SQL Server, and then I start the process again. So keep in mind that we had different times to load the data. Now we go ahead with that. Let me have a look to the, is it running? Yeah, tempting, yes, come on. Starting. Let me see what's going on here. Okay, yeah, it's to process the queries. Okay, now it's running. And you can see here immediately that we now writing massive data, really massive data to every single data warehouse file. When we now have a look to the weight, so what is currently waiting in my system, You will see here that there is nothing, absolutely nothing from the warehouse load. This is an internal thing. Don't think about this one here. These are all internal processes, but you see that the warehouse loading does not have to wait here. Absolutely nothing have to wait. If it takes longer, then it is because of my CPU, which is going high currently. But I can check this because when I see the wait stats, I truly appreciate to don't see the page page latch X and see what's going on here. So currently my system is waiting for CPU, unfortunately. But what you can see here is that the system is permanently writing data. And we are not waiting for exclusive lock. So we see it here. Yes, we have it, but it's IO latches. But have a look to the percentage. It's just only 3% of data. It was not the highest one. This is the lowest one here, one of the lowest one. And my system can perfectly scale now. I hope that we have data here in it. Let me check this. It's waiting. I'm waiting. It's running. But you see here that we now have a more evenly distribution of the writing now. You see that it is around 20 seconds, 18 seconds, 20. Okay, there is one which is higher, can be. But this is, I promise you, just only because I have just only 4 cores here and my system is suffering from CPU pressure here. But the main point, which was that was the customer wanted to achieve, is that every single process can now run in parallel. They had a machine with more over 48 cores, so there were no more problems in it. And you can see it here when we see the differences here in between. So we are between, average is 30 seconds, and we have improved this workload. So yeah, this was the second demo. I'm very sorry for the bad starting because I underestimated to run with OBS and the streaming software, but I hope you enjoyed what you have seen, and hopefully a few of you might think if you design workloads for scenarios for your SQL Server, that you will consider partitioning in that way. So thank you very much for attending my session. I wish you a pleasant weekend. Stay safe and healthy at these times. And I truly appreciate to see you all in a real session, maybe then in Greece. Thank you very much and bye-bye.